and we are working on how can I find the area of a triangle. Something we really want to be good at, something we want to be able to remember and take with us through different grade levels, because at all different levels of math, there becomes a useful time for finding an area of a triangle. So just to kind of review, what is area? Kind of a main idea here. It's when we're measuring the space inside of a shape. So we are talking about, like, typically an analogy would be like a floor plan. Like if you're in your bedroom and you want to put down new carpet on the floor, the area is the carpet. It's the space. And the way we measure that is we cut it into tiny little squares and say, how many squares are in that area? How many little tiny squares of carpet do I need to make up the whole floor? And that's exactly what we're doing, but we're going to do it inside of a triangle. So you probably do not have a triangular bedroom, but there are other things that are in the shape of a triangle that we do need to find the area for. So we're going to practice. We're going to do some examples, and I would encourage you for each example to pause the video so that you can sketch and label your triangle nice and neatly in your notes. So here is the first triangle that you might want to pause your device and start sketching. Okay, so for this triangle we have measurements on all sides, measured in feet, and down the middle. You see that red dotted line with that little box in the corner? That box means it's at a perfect 90-degree angle. I pay very close attention to where that box is. The formula for area of a triangle we've seen in previous videos is base times height divided by 2. We have to find the base of the triangle and the height of the triangle. We don't need all the different sides measured. So in this picture, we have extra information that we don't actually need. So here we go. We're going to do base times height. Where's the base? Well, the base would be at the bottom in this case. Looks like it measures 8 feet. Where's the height? Well, the height is wherever that 90-degree angle is. So this time it's the red dotted line, and it's 7.4 feet. There's my base and height. I don't need the other numbers in this picture. I only need those two. Now I need a calculator. I'm going to grab a calculator and I'm going to multiply 8 times 7.4. So here we go. On my calculator, 8 times 7.4 is 59.2. You can double check me in case I make an error. It's always good to kind of double check some stuff too. Okay, so let's write that down. Area is 59.2, still divided by 2. We haven't done that last step yet. We multiplied the top numbers, but we haven't divided. So let's grab another calculator. Divide by 2. 59.2 divided by 2 is 29.6. So our area is 29.6. And when I write it down, look at the picture, I'm going to put it in feet. So we're going to say feet squared because it's the little squares that fit inside that triangle. 29.6 feet squared. And feet squared can be written with feet to the little 2 power. That's the way we square something. Okay, let's look at another one. Let's do another example. The more we do, the better we get at these. So here's a triangle that you might pause your device and sketch. In this triangle, we're measuring in miles, so this is a really big triangle if we were to actually picture it in real life. And we're going to use our formula. Area equals base times height divided by 2. Base times height. Well, this time, the red dotted line really helps me figure out where height is. That little box, that little square, that 90-degree angle helps me out. So for this problem, my base is actually this one right here. It's the 9.6 miles. That's going to be my base. It's almost like picture taking the triangle and turning it and setting it up so it sits straight up. That's how I find my base. My height is that 90-degree angle. It's that 8.5 miles. So I'm going to be multiplying 9.6 times 8.5. And in your notes, feel free to kind of highlight your base like I'm doing in the picture and your height, because those are the two numbers we're looking for. Like that 10.7 that's in the picture, didn't even need that number. It's a distraction, actually. So I'm going to multiply on my calculator. 9.6 times 8.5 is 81.6. So our area is 81.6 divided by 2. We still got to divide by 2. So what I'm going to do is grab the calculator again, divide it by 2, and I get 40.8. So my area is going to equal 40.8. The units in my picture are measured in miles, so we're going to say miles squared because it's a little square miles, and then I'll circle my answer. Notice my work. Maybe pause and look at your notes. Does your work look like mine? Because I'm organizing it step by step by step. This is very algebraic. I have A equals, A equals, A equals, A equals on every single step. Area equals, area equals, area equals, area equals. It's really important that you organize your work the same way. It's good practice for things we'll be doing in the future. Okay, one more, example 3. This time, here's the triangle you'll have to pause and draw. This is a unique triangle because the red dotted line with the little box, the 90-degree angles on the outside of it when we measure it. And we're going to write down our formula. Area equals base times height divided by 2. Base times height divided by 2. We're going to get that stuck in our heads. Base times height divided by 2. This time, we got to go searching for that base and height. So I'm going to make 2 parentheses, 2 blanks where the base and height go. This time when I look at the picture, the base is that 5 kilometers on the bottom. That is the base of our triangle. So it's a 5-kilometer base. And the height is that 90-degree angle. So it's 3.3. I'm highlighting it in the picture there. So we're going to grab a calculator and we're going to multiply 5 times 3.3. And I know 5 times 3 is 15, so I'm expecting something close to 15. Oh, I got 16.5, pretty close. So our area equals 16.5 divided by 2. So now we hit the divide by 2 button on our calculator and we get 8.25. So area equals 8.25. And the measurement for this triangle is all in kilometers. So we say kilometers squared. Little squares. Remember, every time, square those units. So 8.25 kilometers squared. Circle your answer. And we've got nice solid work here. Okay, so it's time to see if you got this down. We've done a few examples. Hopefully you kind of are pausing as you go and writing all this down so your notes are nice and neat. I want you to try now yourself if you can do some of these. I'm going to do 2 problems. There's going to be an A and a B here. And here are the 2 triangles I'm going to give you. Right now, you should hit the pause button on your device. You should sketch both triangles out and then go through your steps and see if you can do this. Give it a try. Okay, you're unpausing the video, I hope, and you are ready to check your answer. So we're going to go through each of these and see how you did. First one's all measured in feet. We're going to use our formula. Hopefully you wrote down the formula. A equals base times height divided by 2. The base in this problem is the 4.8 and the height is the 3.4. So you needed to multiply on your calculator 4.8 times 3.4 and that gives you 16.32. But you got to divide by 2. And when you divide by 2, you get 8.16. So your answer is area equals 8.16 and it's feet squared. So there's kind of your final circled solution. So how did you do? Look at your work and look at my work. Do we compare? Is yours nice and neat? Did you write the A equals on every step? And really, did you get the same solution as me? Check for all of those things. Okay, let's look at the next one. So the next one, base times height divided by 2. Here's our formula. The base is the 6 at the bottom, and the height is the 4.7, the dotted line. So 6 times 4.7, when you multiply that, is 28.2. And when you divide by 2, that's 14.1. So the answer is 14.1 kilometers squared. Don't forget the kilometers squared, the little km with the squared power. So 14.1 kilometers squared. All right, guys. Well, that's going to almost wrap up our video. I have one final thing I kind of want to show you because you should be kind of asking in your head, like, when could I be finding area in the real world? When could finding area of a triangle be useful? Where are some situations? And so I snapped a couple pictures. I just thought these were like kind of some good things to kind of think about. Might change your thinking when you're driving through town and you see a house. When I look at this house, the first thing my little like math mind sees is that triangle. Look, there's a base and a height. So if I was maybe like needing to re-roof, or not maybe re-roof, but put the siding on again, that blue siding, I might go to the store and they might say, hey, what's the area of that part of your house? Like, how much wood do you need to do your siding? And we'd calculate the area with the base times the height. Or like, check this out, look at that window. That window is totally a triangle. So I see a base and a height. If I was gonna replace the glass in that window, maybe someone breaks the window accidentally, hits a baseball at it, and you have to go buy new glass. They're gonna measure the base and the height and figure out the area for that glass. Yeah, I mean, we could start looking for triangles anywhere. I like this one. If you were designing a pool table and you had to figure out like how many of the pool balls fit inside the triangle. You guys ever play pool? It's kind of fun. So yeah, I just see that base and that height. My math mind, every triangle I see, I'm like, oh, base and height, base and height. So there's a lot of situations where it actually can be applicable in our real world. Hopefully that kind of helps, and I hope you guys are practicing really organized.